question is there a role for government in developing standards for safety V&V and certification for systems which employ AI? So you mentioned a number of standards, right? DO 178, ISO 26262, various others. What are your thoughts on the government sort of provoking the process?
Yeah, so I'll speak loudly. So I'm not, so ISO 26262, just as an example, isn't a certification standard. So we're, it's sort of, yeah, well, I mean, it's also not a, yeah, there's no certification, right? I mean, it's self-applied, right? Your customers typically require you to use it, but it's not a government role yet. Although NHTSA is definitely, looking at it and trying to understand it, and a lot of this goes back to the hearings that were held after a lot of the unintended acceleration examples. But I wouldn't really push for government oversight of the process itself, but I do think that the government should get involved in promoting a regular understanding of what the potential hazards are. Like I say, if I think about all the other automotive systems, we all have fairly standardized understanding of what are the hazards for electric power steering or anti-lock brakes or anything like that, and we all agree on what those are. But in the area of automated driving, we don't really do that. We don't have a good understanding of what the hazards are and agreement on those.
Yeah, I mean, the key word of the question was development rather than enactment. So I think it's, the government can be a catalyst, and I guess that's really the question.
Bill, one of the funny things we found on some of the Doppler experiences was it's not always in any company's or even sometimes a given program office's interest to solve these problems. We learned this when we started working on certification. We were trying to find ways to make certification less expensive and faster. But it turned out that the people we were working with didn't want certification to be any less expensive or take any less time because they were getting paid by the hour. So government has the ability to play a role where nobody else would find it incenting to come in and solve that problem because it's not in a lot of the parties' interest to be better and cheaper.
I think also I was really interested in your talk because it hit upon the idea of what it is that certification actually is. Like in some senses we like the idea of certifying because someone's checking what someone else is doing, but I think that we can think a lot more about what that actually means and what we're trying to get out of it. And I think that would be a very productive conversation that maybe government could play a role in. Also, the other point that came from yesterday was the availability of data to be able to evaluate some of these safety cases. That I'm not going to say whose role that is, but that might be something that government could help quite a bit out.
Yeah, I mean, this was for those of you who were not here yesterday, there was a talk from Robert Raymer at IARPA, who actually had to construct a full research program in order to formulate test data sets for security purposes. Yeah, Randy.
I was struck on your pedestrian detection of the vulnerability to spoofing, and in particular with all these AI systems, you put in standards of what they must, their safety requirements, but that will make them extremely vulnerable to people, just basically it says if there's any person standing at the crosswalk, you have to stop them. So I just have a stream of people that could block traffic forever. And whereas with human drivers, they kind of aggressively start nosing their way through. Sure. And it just, I'm struck by the fundamental challenge of autonomy won't be able to be jerks the way humans do.
Yeah. It's.
Are you developing jerks?
Acceleration.
Very nice. You go to hunt the horn at people?
I want to see how these things work in India, where you'd really have to get people to move out of your way, right?
Cow catchers in the front.
So, to me, that's a big problem because the specification that you want to stop for pedestrians who are in the crosswalk is not what you want to do, right?
Yeah.
That's a way
gross simplification.
Gross
Absolutely.
simplification. But coming up with a crisp definition that really,
Yeah.
my goodness.
Yeah. So it's important to keep in mind that I think that this stage of a safety process is an incredibly expensive stage. The one we're talking about is defining what we actually want to get out of these systems is a huge part of any novel system. I mean, I guess if you're modifying an old design, it's not such a big deal. But this takes a lot of effort to get right, and so. you need to keep that in mind.
Well, and if you go from a human who will be able to override a safety system to totally autonomous, it will just be that. I mean, there's many issues in that, but this is just one of them. Yeah.
The other thing is specifically with respect to automated driving, being overly cautious can be almost as dangerous as being aggressive, because the drivers around you and the pedestrians are all going to be predicting what the car is going to be doing based on their own experience, and so a lot of the issues I think are going to come up are going to be due to overcautiousness.
It's the typical problem, having to look at the overall system rather than just the thing that you're building.
One of the interesting things is that we have, with active safety, we have a laboratory for trying to understand a lot of this stuff. So, I mean, there are already pedestrian detection systems, actually deployed, and then, more advanced ones coming. They're all just, sort of individual safety systems. And so if we get enough data on those, that will help us, I think, as we move into more of the AI approach to it.
Okay, where was Kevin?
Yeah, thanks. So there's a difference, right, between being safe and satisfying safety requirements. And safety requirements are generally hinged on the public's willingness to accept degrees of harm. So there are systems that are highly unsafe, like the medical system, for example, but it's not a problem because people apparently accept that level of harm. What do you see as the role of AI or other approaches to understanding how to calibrate safety requirements based on public's willingness to accept harm in the face of this kind of new generation of technologies? How do we deal with the social aspect of safety requirements?
That's a good one. I mean, that's a very good one. Yeah.
Is that the open bar
Comment,
question?
which is that, when people cause accidents, we have, there's high variance among all of us, right, in terms of how we drive, and high variance within subject as well, depending on time of day and mood and so on, whether we're on the phone, right? And I think there may be a perception that with autonomous vehicles, that there are correlated risks and that there are patterns of failure. It's the black swan, the third piece of the black swan. And maybe that's why people may take any accident involving one of these vehicles with sort of greater weight than an accident involving one of us.
I mean, that's kind of what I was trying to get to with my sort of meta system safety box, because I don't think you don't want to evolve the current safety case. You want to basically create a new one that includes this new understanding, and people's tolerance for risk does change over time, right? I mean, electric power steering is a good example of that. I mean, the safe state for electric power steering is to turn off the assist, and a lot of effort went into understanding whether make sure the car could still be drivable when you turn the assist off. We all learned through the GM ignition switch problem that people didn't really like that, right? I mean, we heard pretty loudly from the public that wasn't any longer an acceptable safe state. So, now we got to go to Plan B, right?
So I'm the Air Force Institute of Technology. We're out of Dayton, Ohio, and right next to us is Columbus, Ohio, which just won the Smart City Challenge. And what's interesting is that some of the startups are not congregating necessarily around the traffic problem, which there's already, a lot of, really great applications and ways on, but actually on the pedestrian problem. And I think there's some really interesting things to look at there in terms of safety, is that people can actually collide with each other, right? And people have more dynamic behaviors. So I've been working in the Air Force for over 25 years now, and we've been looking at planes and vehicles, and everything changes when we started looking at this amount of behavior. So when you look at people and the dynamics and the behavior models that you have to come up with, and the sensor capabilities that you need to come up with, everything really, it gets a heck of a lot interesting, and not necessarily kind of the Chinese cursor.
Comment?
It's interesting over the last 2 days, there was a lot of information presented about possible verification and validation strategies. the two of you, Brian and Doug, are the ones who presented state of where reality meets the road. In that, and both of you identified that, well, we started here, and we did actually get there. Both of you, right? So, can I ask, and it's open to the entire group, where do you see us in actually getting one of these dynamic, I'm not even saying AI here, dynamically changing and, decision-making engine in whatever application to a certification that's formal, like both of you indicated?
I think it's got to come from mission requirements that are recognized as important that people can't live without. Right now, a lot of the stuff I was talking about, we aren't in conflicts where the lack of that has been an issue. But if you imagine a world, maybe it's not even a military world, maybe it's a smart grid world or something like that, where there's a considerable benefit from being able to be more resource savvy about how you're allocating things, because you're going to reduce carbon emissions or you're going to reduce costs for the consumers. It's going to take something like that where people are willing to deal with the risk, because the alternative of statically based configurations that can be proved to an nth degree will not be sufficient to meet other requirements. And I don't know if we've hit that yet, but that's one option.
Yeah, I mean, a lot of it also has to do with the consequences and how novel they are too, right? I mean, if the, quite apart from the risk-benefit analysis, if the actual hazards, if the consequences of the hazards are something that people really don't like, but like burning, or there's certain things that people are more afraid of than other things, those will tend to drive behavior also. But if the hazard is something they're very familiar with, they may accept, with less verification.
I think. Oh, sorry. I was going to say, I feel like there's some kinds of adaptation that can be bounded at runtime, and so we've heard different people talking about monitors of different types, and I think there are some architectural approaches that could work in some situations. Of course, in other ones there aren't. But if we look at those hardest problems, there's actually a number of steps between here and there. I think there's going to be a lot of trained systems, machine learned systems that are valuable that maybe have bounded adaptation. And so it's kind of like a partial acceptance sort of thing that might get us there, where we start out where we are now, and then we start to come up with safety cases for systems that have been trained but can be bounded in certain ways. And then I keep coming back to what you're saying about sort of the cultural challenges here, and then we start to all feel like we're being responsible and putting forward these arguments, and then we push it a little bit more and we learn more the whole way and finally get there. Like I think it's a gradient, I guess.
You're talking about a phased deployment with growth and scope and capacity over time.
Yeah. And I mean, there are other analogies here, right? Like, so adaptation could be a frequent patch cycle, right? Like a frequent firmware update cycle, right? And to have V&V systems or V&V processes be able to handle that effectively, there's going to be huge need for that, and so we'll start to see these things get adapted.
So I was going to say that there is a societal, psychological issue that I think needs to be taken into account. So you said if it's a familiar issue, then people will be more likely to accept it. I think that's not quite true. So the first time an autonomous vehicle kills a child, it's not going to help to say, oh, but human-driven cars that kill hundreds of children every year. This is going to be a big, big, big deal, and
right.
I don't know how to I don't know how to deal with that. But I think as a community we're going to have to figure out how to deal with that from a perception point of view, because people expect, I think, perfection from these types of machines, and when the machines aren't perfect, so for things like anti-lock brakes, it's okay. If they make a mistake every once in a while because the person is pressing on the brake, they could say, "Oh, I hit the brake too late, and that's why it failed. It wasn't the machine." But with autonomous vehicles, there's not going to be that excuse, and I'm really worried that when even though you say, okay, we can get a 10-fold decrease in deaths in the United States with autonomous vehicles, the remaining 3,000 deaths a year from autonomous vehicles not going to make people happy.
No,
I just want to say, from a policy perspective, think about Andy Grotto's talk. The parable of GMOs in Europe is really pertinent to this, and I think it's something we all have to be kind of keenly aware of. It's just that we're going to be held to a different standard.
I know, but the difference is that the GMOs, right? Those were issues that people weren't familiar with. So, but this was an issue that people are familiar with, and it's still.
The engineering of these systems?
No,
the
driving.
Deaths from driving. And people are still going to be very, very concerned about that.
I would submit, though, that killing a child is always an emotional event. So, I mean, yeah, I would say that would fall into the category of bad hazards that people would hate. But, yeah, I mean, but even there.
But are people going to say, oh, it's still safer than
No,
having
no,
humans
that's why I'm
driving?
saying they won't make that cost-benefit
right,
analysis.
right. Of
course.
They're only focused on the consequences
Yes.
of that particular.
Of course, you could also maybe mitigate that by highlighting people whose lives have been saved by these systems too. I mean, maybe there's a bit of, we need to be even-handed there too.
It's hard to tell because the airbags is another.
I
We
agree
used to
with
kill people with airbags.
Yeah.
Small children.
Yeah.
And so then they backed off on the power of the airbags, and they also made it very unlikely that they would go off. And then people decided that not having the airbags go off was more of a hazard than or they expected more perfection in the decision. So people's understanding and tolerance of risk changes over time. They need to be sensitive to that.
Humans drift, yeah, we heard that one earlier too, yeah.
Last question.
Automatic driving cars have been mentioned throughout the day. I was involved in a real scenario in Interstate 80 that I'd like to see addressed. All the things I've ever seen have been slam on the brakes is the solution to the problem of whatever, the pedestrian in the crosswalk, or the guy in front of you stopped too fast. I was on Interstate 80 in a construction zone when a vehicle came across the interstate. He wasn't going with the traffic, he came across it, out from behind a bulldozer, 20 feet in front of me. If I would have applied the brakes, I guarantee I would have hit him, because there just wasn't any way to stop at the speed I was going in 20 feet. Instinct kicked in, and I floored it instead. So I'm now going full speed at this guy so I can get in front of him and go around him on the berm. Is there any autonomous, I know the answer right now is no, but is there any future autonomous vehicle, anything, that's going to make that kind of decision to prevent an accident?
Look in the air. I think flight systems are where you'd see analogies to that, because they have to actively respond to cases. I mean, that's one thing that makes aerial vehicles much harder.
Right.
Exactly.
So on the note of full speed ahead, I want to thank the panel. All the other speakers today, thank you very much.